All right, June 2015, multiple choice. Let's take a look. All right, so we'll start with a modeling question here. This is one of those where like they give us a linear equation and they want to know what do these numbers mean. So based on this model, which statement is true? So in this case, it says airing a commercial on TV. Excuse me, N is how many times the commercial is aired. What do we think here for choice one? I'll give you a few seconds to look it over. So just when we think about slope and y-intercept for problems like this, y-intercept is going to be some starting amount, something there's just like the flat out fee, the deposit, whereas the slope is going to be something that's reoccurring. What do we think for number one? Yeah, you could say your answer if you want. Choice three, Jamila says. Choice three, a bunch of people say. Yeah, choice three here. So let's break down why. $900 to produce kind of implies like, hey, we paid $900 when we made this. 110 each time is the key word there, right? This is it. This is implying that, hey, this is a rate that happens over and over again. If you look through some of the other choices, choice one, $0. I'm not sure why you'd say that. Choice four also doesn't make any sense. So it's really between 2 and 3. And number 2 just switches up what's the y-intercept and what's the slope, right? Slope we're looking for per each that indicates some sort of rate that occurs over and over again. Going back to the beginning of the year, you might remember this question. It was probably thrown in on a lesson or a test. We looked at distance versus time graphs, and these were called speed versus time graphs. And there was a slight difference between the two. On a speed graph, which we have here, horizontal lines mean something different than if they're on a distance graph, right? Before we even look at the question, let's just like talk about all this. If we change this to distance, so hypothetically, if I change this to, hey, how far this person was from their house or whatever, what does a horizontal line mean on a distance graph? What does a horizontal line mean on a distance graph? Yeah, on a distance graph, a horizontal line means, hey, I'm not moving, right? Well, maybe I'm like going like this, but I'm not like physically moving, getting any further. On a speed graph, doesn't mean that anymore. On a speed graph, what does it mean? You're going at a constant speed, right? The positive slopes are going to be cases where you're accelerating, and the negative slopes are going to be cases where it's called decelerating, like slowing down. Where's the only time that you're stopped on a speed graph? Where's the only time that you're stopped on a speed graph? There's only one, when you hit rock bottom. Yeah, when you hit the x-axis. In this case, it's only like right here and right here. The only time you're stopped on a speed graph is if you're touching the x-axis, because that's a speed of 0. All right, so a quick little refresher. Let's see, what is this one? Between 9 and 12, what's happening? What could be happening? So what's happening in that section here? What do we think? Person standing still, increasing, decreasing, or jogging at a constant rate? Choice 4 is correct, constant rate. What do you think most people would incorrectly put for this? And I do remember people putting this as a choice. This was my first year at MS67, this exam. Choice 1, yeah, standing still. That would be if it's a distance graph. So always check your axes, right? That one little word change, choice 1 could be the answer. But in a speed graph, just think about it too, even if you forget, like, wait, it's staying 6 miles per hour. Why would they be standing still if they're going 6 miles an hour? Very good. All right, number 3. What topic is number, because it doesn't say it, what topic do you think this number 3 is getting at here? Good, Ethan, dots, or more generally, good, Kira, like factoring. This is a factoring question. At the end of the day, number 3 is a factoring question. They can add whatever like nonsense they want. They want to know, hey, do you know how to factor this expression? And this is dots. Good, Ethan. So which choice does dots correctly? Which choice has done dots correctly? With dots, remember, we need a plus and a minus sign. So just using that information, I know it can't be 3. The other thing with dots, the bubbles should look the exact same, so I know it can't be 4. Listen to kind of my reasoning. Obviously, if you know how to do it, you know how to do it. But I can also make the problem slightly easier on myself. So now it's between 1 and 2. It is choice 2. It is choice 2, right? What do we do with variables? We cut them in half. And with numbers, we take the square root. The trick with dots, don't do this if you have a nice easy dots. People do this, right? They say, oh, x plus 50, x minus 50. Yeah, we cut variables in half, but we don't do that with numbers. We're taking the square root of any constant. Yeah, and the thing that's wrong with 1, if you FOIL that out, if you multiply that out, x times x is only going to give you x squared. So nice, a decent easy start here. First 3 questions we're flying through. There are some harder multiple choice, unfortunately. All right, which one is a function here? Hold up, I'm going to turn the chat off for a moment just so we can, some people might want to take their time with this one. So turn the chat off. When I turn it back on, you could type your answer in. We have 4 tables. Which one is a function? We're not saying linear. If I say which one's linear, that means something else. But which one is a function? Which one is a function? You have an answer and you want to send it in. Which one is a function? I don't think anything's linear here, right? Is anything linear? No. So why is the choice 3? Choice 3 is correct. A few people are writing 3. X can't repeat. Good, Krish. Does it matter that choice 3 has this? People might be turned off by that, right? Like, wait, there's this repeating thing. I see 2, 2, and 4, 4. No, y can repeat. Every other choice with functions, we really care about, hey, is x going to repeat? The only other added trick is it has to repeat to a different y value. So sometimes they'll throw this in. Let me see if I could fix one of these. So let's look at like this table. Pretend the 4 is not there. If it said 2, 3, and then it said 2, 3 again, this would technically still be a function. So that's the only like other thing. People will just look quickly and go, oh, I see 2 2s. Did it really repeat though to a different y value? No. So just be on the lookout. I've seen that come up every so often. But otherwise, x repeating will generally get you there. Doesn't matter if y repeats. You're looking for one input to correspond to 2 different outputs. Okay. Ooh, today's lesson. Linear inequalities. So what I would recommend for a question like this, we talk about, and we did it today, there's 4 things you have to know. So maybe make a note of what are the 4 things here, and then we'll see which choice matches that. It looks like just knowing the y-intercept and slope. Well, right away, which 2 choices can we cross off? Right away, which 2 choices can I cross off? 2, 3, and 4, I think, are even more obvious. Why am I saying more obvious? I know the y-intercept is 4. All right, so right away, 3 and 4, get them out of the ballgame. So now I don't even have to worry about slope because I see the slope is -3/1 for both of them, and it is. I know the y-intercept is 4. So now it's just going to boil down to, we know it's a solid line. That doesn't help us. It's going to boil down to the shading. Did we shade above the line or did we shade below the line? We shaded above. So which choice reflects a shading above? Which choice? Choice 1. All right, 1 through 5. We're flying through these. Any questions with 1 through 5? 1 through 5. Nice easy start. Nice easy start. Ooh, okay. Okay. So this is where we start to pick it up a little bit. Mo's farm stand sold a total of 165 pounds of apples and peaches. She sold apples for $1.75 a pound and peaches for $2.50 per pound. If she made $337.50, how many pounds is she? So anyone, what topic is this? You're not going to be asked that on the Regents, but I like to just see like, okay, do we know what this is getting at? What topic is this, do you think? Yeah, this is a system question. So this is a system of equation, right? Okay. So I'm just going to quickly, we're going to do this two ways. I'll show you kind of the real way of doing it. And being that this is a multiple choice, I'll show you a calculator, maybe. I'll show you a calculator way of doing it as well. Okay, so I know that a plus p should equal 165, and I know 1.75a, so I'm going to make this system very quickly. Well, I guess you have a few options for how you do this. You could do kind of guess and check. Being that it's multiple choice, I could plug in, and you might be saying, isn't that just one variable? You could figure out what the other variable is. For example, in this case, all the choices represent peaches. So for choice 1, that means p equals 11, which means a would equal 165 minus 11 or 154. So you can kind of go through like that. That's going to take you a while. You could obviously solve it, you know, how we normally solve it. And we could do that just to review. The other option I would offer for a system multiple choice, and we did this on the systems test, is do we remember using this option? The matrix option. The matrix option. Do we remember doing matrices stuff? Maybe? Okay. So let's solve it the real way first. Let's just do that, and then we'll talk about matrices. Matrices are something you learn in a more advanced math class, but you can use it to help you solve systems. Your calculator has like a system solver in it that most people don't know about. So what I am going to do is elimination. You could do substitution as well. And why am I telling you that for this question, but we learned all these things? Because this is a multiple choice. Most of the time on a written question, we want to show things algebraically, but if we have a multiple choice, hey, let's take the shortcut. That's fine. But we'll do it the real way first. So I'm doing elimination here. You're more comfortable with substitution. That's fine as well. Ooh, and I should have read my, oh no, I did, okay. Because it just wanted to know peaches, so I got lucky because I'm solving for p. I could stop once I solve for p, which is good. All right, I got p equals 65. So this one wasn't too bad. Just be careful if you solve for apples, you might circle like the apple choice right away. Like apples are 100 in this case, but I wanted to know just how many peaches. So p, obviously. I did elimination again. I got p equals 65. All right, now I don't want to get too crazy with this because if you understand that, that's obviously better. But matrices involved hitting its, I don't want to screen share and kill some time, but second x to the negative first. It's literally a button that says matrix on the left-hand side. I'll quickly show you this. You make a 2x3 matrix. You type in just the numbers alone. So 1, 1, 165. Let me type it and then I'll hold it up. I do have a YouTube video on this I can link. So you make a 2x3 matrix. You might still have it saved from when we did it in class. Notice I'm not typing any variables, no math symbols, just the pure numbers out of this, right? Anyone remember this, or am I crazy? Don't answer that. Okay. Now, once you type it in, this is like a little bit of a hack that, you know, most algebra people wouldn't be aware of. Once you type it in, you're going to quit. So quit, get out of there. Go back in, and you're going to select RREF under matrix math. And if you do it correctly, you'll end up getting this screen. So you have to know how to interpret it. So what this is saying now is 1x is equal to, or in this case, 1a is equal to 100, and 1p is equal to 65. So if you type the system in correctly, it will solve it for you. Grace, I would recommend, I don't want to spend too much time over that, but it's second x to the negative first, but the button below math. Second, and then the button below math. I do have a video. I'll try to find it when you guys are working on one to link it. You would just put the number. So like, look at the system we made. You would just put 1, 1, 165, and then 1.75, 2, just the pure numbers. No symbols, no So just this is what you would put in your little 2x3 table. You quit, go back in, scroll to the right, and then you have to select like RREF and for the matrix that you typed it in for. Okay, don't get too hung up on that, but it's a little bit of a hackware. All right, okay. These are called step functions. They're piecewise, but they're more specifically called step functions because they look like a staircase. Morgan can start wrestling at age 5. He remains in that division until his next odd birthday when he's required to move up to the next division level. So like every other year, I guess, he moves up. Which graph correctly represents this information? So at age 5, we want him in division 1, but then every 2 years after that, he kind of bumps up to the next division. You could put your answer in. Yeah, choice 1 here. So let's check out choice. Well, choice 3 wouldn't make any sense because choice 3, being that these are both filled in, implies that when he's 7, he's in division 1 and 2 at the same time, right? This would not be a function. There's a few things wrong with this one. This one is saying at age 7, he stays in division 1. So it's basically testing out the open versus closed circle. And the correct answer here is 1. Hey, the second he turns 7, it's open, he bumps up. He stays in division 2. The second he turns 9, he bumps up. So see how there's an open circle on the right, but a solid circle on the left? That's what we're looking for in this one. Yeah, this is a kind of a weird question. What happens when he's 17? 17 would look like this. Or maybe he stops doing karate or something, or wrestling. All right. Ooh, okay. Which one is not always true? We talked about this. This was like when we did those cases. Take a minute to read it over. I'm going to look through my YouTube channel for a moment to find that. What the heck? Okay, found the video. Found the video. It does exist. So if you really wanted to know about matrices, it's a matrices video. It's not a Rickroll. Or is it? All right, what do we think here? Which statement is not always true? The sum of two rational numbers is rational. That's always true. If you add two fractions together, you get another fraction. Choice 2, the product of two irrational numbers is rational. That's like the exception. It's usually the other way. So yeah, that's not always true. That's kind of weird that they gave us the exception there. So if you multiply two irrational numbers together, will you always get a rational answer? No. If I do like rad 2 times rad 3, 2 irrational, I get an irrational. Usually that's the case. What they gave in choice 2 is like the rare exception. That happens when you do like maybe the same radical times itself, or like rad 50 times rad 2. It sometimes works out that way, but usually it's irrational. Let's look at the other choices. Rational plus r plus I is I. That's always true. The product of a non-zero rational and an irrational is irrational. That's true. The only exception we had was using 0. So by saying non-zero, they take away the exception there. Choice 4 is always true. Any rational times an irrational will be irrational except for 0. So choice 4 will always work. All right, we have a square root graph. We've seen this exact question. I know for a fact I've given this one to you guys. They kind of write it weird. That's just saying like, hey, x is the variable here. What's the domain of this graph? What's the domain? So domain is basically saying, hey, what x values work in this graph? What x values are allowed in this graph? What x values are allowed in this graph? It doesn't have arrows on both sides. Most functions are going to be all real numbers for this, negative to positive infinity. But square root functions have a restriction. The line thing is just doesn't mean anything, Kyle. It's saying like x is the variable. It's kind of like saying end or something. Yeah, you can say the choice. Ooh, we have answers all over the place here. Yeah, people are saying 3 or 4. The answer is 4. Why is it 4 and not 3? Why is it 4 and not 3? 3 says it can't actually equal -4, but we even see in the graph a solid dot there, solid point. You could equal -4. You're allowed to take the square root of 0. Guess what the square root of 0 is? 0. So you're allowed to do that. It's negatives that you can't. Anything anything smaller than -4 is going to create a negative onto the radical, which we can have. So 9 is choice 4. All right, number 10. What are the zeros of the function? Now, again, a multiple choice. We really care about the process for this. So let's talk about some options we have to solve this. I could type this into y equals. And look at the choices. They're all kind of nice integers. There's no crazy decimals. So I could just maybe go to my table. Second graph, not second table. Second graph, go to my table and just look for the zeros. So that's an option. What's another option for how we could solve this? We could actually factor it. Being that all the answers are integers, we know it's going to be factorable. No one should say here quad formula. So you have those two options. I'll do the factoring route if you're having trouble. If you want to do the calc, go right ahead. This is one to be careful of because it seemingly looks like two things can work here. Do our sum product. Also, you don't want to stop right here. CTS. You get two answers of other way around, Ethan. Did you just? Yeah. X equals 15 and -2. Choice 4. 15 and -2. All right, number 11 is an average rate of change question. It says to the nearest tenth. Does anyone remember the phrase average rate of change? What does that mean? What does it connect to? You wouldn't want to do CTS there because he was just joking. Like it was an odd B value. Why would you want to do CTS? Yeah, AROC stands for, but we called it AROC. And what does AROC get associated with? The only thing I remember is that it's called AROC. What the heck? Wait, what? How did I just do that? I just like used my finger and it erased it. That's weird. Let me try to do that again. Wait, what? All right, let's not do that. What word does AROC is associated with? No. Kyle, yeah, I know AROC means average rate of change. Slope. AROC and slope are basically the same thing, right? It's just that AROC is for nonlinear functions. So they're basically the same thing, not literally the same thing. So we're going to treat this like it's saying, hey, find the slope between the original photograph, so this is the original, and the fourth enlargement. So to find the slope, we're going to excuse me. We're going to find the change in the y values or the outputs and divide them by the change in the x values. Thank you. Thank you. Hit it. want to take a second to do that. What's the change in the y values? Change in the x values we should be able to figure out right away. That's just 4. Remember, slope is rise over run. So change in the x values, that's what, 21.6? So 21.6 over 4. Where am I getting 21.6? I'm subtracting the outputs. 36.6 minus 15. 4 is 4 minus 0. Change in y over change in x. You forgot all this. A-rock is slope. A-rock is slope. And the answer we get, choice 3, 5.4. Why did I circle 0, 15? This one was a little vague, I guess, but it said original photograph. So if there's no enlargement, that is the original photograph. And then it says the 4th enlargement. So 1, 2, and 3 here are pointless. You don't do anything with the 1, 2, 3. Okay. Cool for that. All right. So this one looks kind of scary, but we've seen this question before. It's like making this connection between factors and roots. So write down where the roots are. So the roots occur at -2, at 1, and at 3. And now we can unsolve them, I call it, to make them factors. This is like the opposite of what we usually do when we solve something. And now let's look at one of these Roman numeral ones. Okay. So there's another connection here. Usually the question just looks like that and we kind of circle it. So what's the added step that they did here? Because I don't see any matches to what we have. What step did they add? We're not factoring. The opposite of that, Grace. Yeah, they multiplied like some combination of them, 2 at a time. So like they maybe multiplied these 2 together and left that one hanging. They maybe multiplied these 2 together and left that one, because I'm seeing like a squared with the remaining bubble there. So let's just quickly think about some of the possibilities we can get here. If I multiply these 2 together, I'm going to get x squared plus x minus 2. This is kind of annoying. So let's see, that would be, so that's in choice 2. That looks good. Use logic to erase anything here. Choice 1 is gone. All right. And now we can just check, I think if we just check 3, we should be good. So let's see if 3 works out. So 3 is saying x minus 1 is left behind, and the other 2 got multiplied. So if we multiply these 2 together, and again, you could do box method here if you're more comfortable with it. I'm just kind of foiling them out. We should get that if you multiply those 2 bubbles, which is what we don't get in choice 3. So 3 doesn't work. Oh, we still have to check 1. What? And for 1, sorry, x plus 2 is left behind, which means these 2 get multiplied. If you box those 2 out, you would get x squared minus 4x plus 3. Does that make sense for choice? No. So just 2 only. Yep. Kind of a weird one. Usually, like when we saw this question, they usually leave it in that bubbled form. They took it one step further by just multiplying different pairs of them out. So it's kind of annoying because you have to go through like the 3 cases. So that's why I was highlighting them, and I know I was doing it quickly, but like, all right, x minus 1 times x minus 3 gave me x squared minus 4x plus 3. So that's why I put an x next to Roman numeral 1. I didn't get that trinomial I was looking for. Kind of a weird phrase one. I mean, the other option is you could do this on your calculator. Now that I'm thinking about it, you can go in one by one, type these into y equals, go to your table, and just check that they have the same roots at -2, 1, and 3. You could calc this. Yeah. Well, I don't know if you're being serious, Grace, but you could do that. Okay. Okay. So which function, we have bacteria versus days here, which function would accurately model the technician's data? So let's play the logic game a little bit. We're getting into some of these like weirder, tougher questions. So let's hit the brakes for a moment here. This is like, oh God, I don't know what to do. So let's get into this process of what we can maybe cross off before we even get into it. Let's look at the table. All right, I see it starts at 0.25. It's 2, 15,000, 4, and then it's like 9 million. So we have in choice 1 and 2, those are exponents. We have exponential functions and we have linear. So which we can cross off 2 just using some kind of logic or common sense. Which 2 could we cross off here? We can cross off 3 and 4. 3 and 4 are linear models. 3, if you distribute the 25, it's just 25t plus 25. Those are linear. Does this have a constant rate of change? Is this going up the same amount? No. Okay. Goes up like 15,000, then it goes up like 9 million. So no. Now it's between choice 1 and 2. Now we could just think about exponent rules. If you plug a 0 in, 25 to the 0 would be 1. If you plug a 0 in here, 25 to the 0 plus 1, 25 to the first power would be 25. Choice 2 works. I didn't even really get into anything else just besides some simple logic with ruling out the linear choices, and then I just plugged in a 0. You could type in, if you want to double check, type in 25, hit the exponent button, x plus 1, don't use t, and then go to your table and just verify that you see 0, 25, 2, 15,000, blah, blah, blah. This is a good example of like taking a question that looks scary and looks difficult and kind of making it simple. Why did we cross off the linear? This did not have a constant rate of change, just even eyeballing it. You don't even have to like do slope. Is this going up the same amount each time? Definitely not. It's exponential. It's going up rapidly. Questions with that? I don't know. I started a little late, so I'll kind of keep going. Why don't we say till we finish the multiple choice? If you have to go, you have to go. That's fine, but I'll try to finish the multiple choice. All right, which of these has the largest maximum? So what does maximum mean again? What does maximum mean again? Yeah, it's specifically just the y value, and obviously the largest y value. That has nothing, in this case, it is going to be a vertex, right? But it has nothing to do with the x value. When we say minimum or maximum, it means high, Yusuf. I guess that's true. But it specifically just refers to the y value, okay? So if like there's a vertex at 2, 3, you wouldn't say the maximum is 2, 3. You'd say the maximum is 3. It's specifically just the y value. Now for choice 4, we could see the maximum is around like a little bit above. Let's just guesstimate. It's like 4.5. We already see that the table is beating that, so choice 4 is out. The maximum here is not 9. The vertex is kind of hiding in the table. Let's call it 9.5, just to keep like some sort of number in our mind. No, it was just today. Now, what we can do for choice 1 and 3, well, for choice 3, let's work with, we know the maximum is going to occur at the vertex. So I could do my little vertex calculating, negative b over 2a. So 12 over negative 10. That's going to be negative 1.2. And then you can plug a negative 1.2 in for x. Hold on, I'm just doing that. And whatever you get for your output will be your y value. So like, I'm basically finding the vertex. The y value here is 11.2. So he's winning so far. Let's just see choice 1. You could also use your calculator. I'll show you how to do that. So I'm going to type this one into y equals, choice 1 into y equals. I'm going to observe the table. I'll hold it up. This is what the table looks like for choice 1. Ah! That could have been bad. This is what the table looks like for choice 1. So the maximum is like around 6, a little bit larger than 6. So who's winning this game? Choice 3. Choice 3. How about my calculator? You have to go. Bye, guys. Sorry, we were starting a little bit late. So you could do a few. I tried to show you a little bit. I mean, 2 and 4 just visually looking at the maximum, but 1 and 3, what are your options? You could calc it and just kind of guesstimate, eyeball it, or you could actually do a vertex calculation. Vertex calculation is going to be the AOS formula, negative b over 2a, and then just find the y value of that x value. So like, how did I get 11.2? I plugged in a negative 1.2. Plug in a negative 1.2 for x, and that will give you your y value. Okay, 15. Okay, so for 15, we're told f of x and g of x, and we want to know for which value of x is g of x larger? Is he having a larger output? So this is a great example of one that could all be done on a calculator. So if you have a calculator on you, go ahead and type in these two functions. Should look like this. So 3 to the x power and 2x plus 5. And g of x is the 2x plus 5. So this question is asking like, hey, when does that bottom equation win in terms of outputs? So I'm going to go into my table, and we want to know, we're going to check each of these x values. So at negative 1, I see that f of x is 0.3 and g of x is 3. So that's our answer right there, choice 1. When x equals negative 1, look at the red. The red is g of x. 3 is greater than 1/3. The other choices, like for 4, we have 81 versus 13. So no, it's not going to win that. The only time that the linear is winning here is at negative 1. At g of negative 1, it is 3, and f of negative 1 was 1/3. So that's the only case where that happens, where x equals negative 1. This is all on the calc. Have a nice day if you have to leave. All right, we saw this question, if you have a good memory, on your stat test, I believe, or in the review sheet at least. Which statement can you conclude based on this study of soda versus ice cream? This implies that one topic, it was like a note I asked you guys to write down in the lesson we did on correlation. Correlation doesn't imply causation, right? So look at like Roman numeral 1. Can we conclude that, hey, obviously there's a strong relationship here, 0.96, but can we conclude that eating ice cream causes you to drink soda? No. Correlation doesn't imply causation. So what is the answer here? Like 1 and 2 should be out right away, the word causes. All I can say accurately is choice Roman numeral 3, which is confusing because it's choice 2. I can only say that there's a strong relationship. There's a strong correlation. I can't say, oh, it causes, if you eat ice cream, you're going to drink a Coke. No. I could say there's a correlation, there's a relationship, but there's not a causation. Yeah, you had that one on a test. Yep. Ooh, okay. So for exponential functions, we have this idea. Remember doing these, like some problems are 1 plus a rate and some problems are 1 minus a rate? You guys had the partner project where you looked at like houses and cars. We did lessons on this. So obviously this is going to be the case where we're adding a rate. This is called growth. The other one was called decay. And they want to know, what was the percent? Usually like the sample problem we did was like, oh, Chase Bank gives you 5% interest. So a good way to do these, if they give you some like bubble and you want to know the percentage, is to take away 1, right? Because remember, 1 was added to this at some point. So if we take away 1 from the 1.07, we have 0.07, 0.017. So we take away that 1. Now that's the rate as a decimal. How do we make this into a percent? So as a decimal, the rate is 0.017. Look at all the choices. They're all in percent form. So how do I make it into a percent? Good, Kira. Multiply it by 100. Multiplying by 100, you could always do without a calculator. Move the decimal over twice. And look, be careful. All the choices look like they're good. Which choice do we think here? Which choice here? Choice 2. Choice 2. You had questions like this. I don't know if you had this exact one, but like, let's say, this represents a model for something. the population somewhere. Is the population going up or down in this made-up example? Just by looking at the base, is the population going up or down? Going down. Anything less than 1 will be going down. And what's the rate that it's going down? What's the rate in this case? 0.08. Kyle, that's the decimal as a percent. The rate would be 8%, right? With these cases, I said, like, think about what's missing from it being 100. So in this case, what's missing from this being 100? That's kind of like saying 92%. It's 8% decay. You don't say that it's 92% decay. You'd say 8%. 8% cure, not 8. Right? Because it would be 0.08, which would become 8%. All right, we'll do a little review lesson, obviously, on exponential functions coming up pretty soon, but that was a good review to throw in here. All right. When directed to solve this quadratic equation by completing the square, Sam arrived at this step. Which equation could he have started with? So what you can do for this one is kind of like, hey, do I have to do CTS? But they already did CTS. So what you're going to do with this one is like box it back out. You're going to do x minus 5 halves times x minus 5 halves. They wanted to know the original. So even though it says CTS, you're just going to box this. It's basically like a FOIL question. And just for time, I'm going to go ahead and do it quickly. 5 over 2 times 5 over 2 is 25 over 4. You're going to get negative 10 over 2x when you combine those, which is just going to be negative 5x. So which choice do we have here? Oh, and I forgot about equals 13/4. So if you set this equal to 0, you would subtract 13/4. 25/4 minus 13/4 would be 12/4, or just 3. So the constant here is plus 3. The b value is negative 5. It's going to be choice 4. Okay, again, 10 over 2 becomes just 5x. When you combine 25/4 and negative 13/4, you get 12/4, or just 3. So basically a box method question. I think you guys had this one on a test. Number 19 is a literal equation. It asks us to solve for t. We just did this topic in review. So let's solve for t. We should know how to do this. I like to get rid of the fractions first. How can we get rid of the fraction in this case? How can we get rid of 1/2? Are people still here? Yeah. We can multiply by 2. Let's get rid. What are we solving for? T. Let's get rid of the a. We could divide by a. And just clean it up. So we have 2d over a equals t squared. And now what can we do to solve for t? We could take the square root. Taking the square root will undo the square. So 2d over a, radical 2d over a, choice 2, choice 2. We've seen this, we saw this question, you guys remember this one? In our stat lesson, this had a little bit of a trick to it. If you throw a 10 into the mix, most people got this incorrect because they're like, oh yeah, the mean and median will both go up. However, the mean goes up, the median actually stays the same. Does anyone remember why the median stays the same in this problem? Kind of a trick. The median stays the same because right now the median is 1.4. And if you look, it's kind of bookend by 1.4. So even if the median slides over 1, it's still going to remain 1.4. So it's shifted over, but it still stays 1.4. And you could obviously like one var stats this and verify and write them down and stuff, but you could also just look at it and know the answer. It's a little bit of a trick question, but we saw this exact one previously. You're going to notice this a lot. You're like, oh yeah, this was on a test. This was in class. We did this. I throw a lot of Regents questions on everything. All right, number 21, what would be a correct next step? So what would you do next if you were solving this? Let's figure it out ourselves first. What would you do next? If something's squared, what can we do to solve for it? Not box it out. If we box it out, it's going to make the problem more confusing. Take the square root. This is the square root property. When something's squared, we take the square root. What's the square root of 25? Don't say 5. Plus minus 5. Plus minus 5. Okay, choice 1. Choice 1 would be our answer. You got away with that even if you didn't put the plus minus. What's wrong with choice 2? They just put a plus minus sign and left it 25. Choice 3 and 4 are like people that incorrectly boxed it out. Why would you box it out? Did that help you solve it? Look at choice 4 as if you correctly boxed it out. Would that have helped you? No. Taking the square root, you're like a few moves away from finishing. All right, and I apologize. Let's try to get the multiple choice done here. We have a sequence question. What I like to do for these where they give you something weird, like write down the numbers of how many boxes there are. So the pattern here is starting with 2, add 4 each time. So this gets into explicit and recursive rules. Like Roman numeral 2 works here. Roman numeral 2 is quite literally saying the first term of the sequence is 2, and then the pattern is to keep adding 4 to go from one term to the next term. That's what those things mean. So Roman numeral 2 works here. The explicit formula for sequences looks like this. It's a sub n equals a sub 1 plus the common difference times n minus 1. So a sub 1 in this case is just the first term. What's the common difference in this problem? The common difference is what are you adding between consecutive terms? The answer is 4. Now, you write this and you're like, all right, I don't see that anywhere. But be careful here. Because after you clean this up, watch what we get. I would distribute, 4n, I get minus 4. I have a plus 2, so minus 4 plus 2, I get this. All of a sudden, you might notice Roman numeral 3 is the cleaned up version of that explicit rule. So 2n3 here, 2n3. All right, we're getting there. I did want to promise to finish these because I was starting late. All right, number 23. Am I even going to bother factoring? No, look at the choices. They're all radicals here. So I have one of two options. Have a good day, here. I could do CTS or I could do quad formula. It's kind of set up nicely for CTS, so I'm going to go ahead and do that. I'm going to give myself some space. So for CTS, we want to add that number to both sides. In this case, that number is going to be 16. Now the trick with CTS, this number will always be half of whatever B was. We're going to get 40 on the right. We take the square root of 40, put plus minus. 40 we can simplify to radical 4 and radical 10, which will become 2 radical 10. We move the 4 over by adding it, and we get 4 plus or minus 2 radical 10, choice 1. And again, you can do quad formula. I usually like to do CTS if I notice that x has an even number in front. It's usually going to be a little bit faster. Where did I get 16 from? That magic number that you add to both sides is always going to be half of the b value, in this case negative 4, squared. Squaring negative 4, you get positive 16. It'll always be positive since you're squaring it. Your bubble will be half as well. So it said minus 8. That's why my bubble was minus 4. And then you use square roots. Remember with simplifying radicals, like you try to pull out a perfect square. So 40 I wrote as 4 times 10. And last one, Natasha is planning a school celebration, wants to have live music. She has found a band that will charge her $750 and a caterer who will provide snacks and drinks for $225 per person. Her goal is to keep the average cost per person between $275 and $325. I'm sorry. If her goal is to keep the average cost between $275 and $325, how many people must attend? How many people must attend? Okay, so this is an interesting one. We have like this sandwiched inequality here. So there's a few ways we can do this. We can consider kind of using the choices to our advantage. And it is a little tricky because we have this like sandwiched inequality, which we're not really maybe super comfortable with. When I say sandwich, like the variable's kind of in the middle. Luckily, we don't have to create this ourselves. It is multiple choice. That's what I'm saying. We can use this to our advantage a little bit. So let me kind of get my work set up here, and then I'll explain it. So what I'm calculating, what I'm showing right now is this is what she wants. This is what she wants. I'll explain it. Give me a second. Give me a second. Okay, so where did I get this work from? What does it mean? Is anyone listening? No. So what is it? What are these two calculations I'm showing here? These are showing how to calculate the average price per person. And this is what she wants. She wants it to be somewhere between $275 and $325. So every person costs $225, like a plate, basically, the $750. And I'm dividing by however many people go. That will give me my average. In other words, if 100 people go, I could add all those up and then divide by 100. So what we're going to do now is solve each of these inequalities. They're equations for now, but we're going to solve these equations. I'm going to multiply by P to get rid of. And now I get this. Same thing over here. Let's just kind of solve one at a time so we don't go too crazy. This was a weird, this year had a few weird multiple choice. Started off like super easy, and then it did get weird towards the end. This is like not a traditional question. I would move 225 to the right. 275 minus 225 is 0.5 P equals 750. Oops. And I could just multiply that by 2. I get 1,500 equals P. All right. So one possibility is 1,500 people. And now if we use the same logic with this one, you're going to get 1P equals 750. Okay. So the higher end was 1,500 people going. The lower end was 750 people going. It's going to end up being choice 4. That's why the answer ends up being sandwiched between those two. So anywhere between 750 and 1,500 people can go. Kind of a weird question, I know, but this is one way you can do it algebraically. So this was the multiple choice for the June 2015. If you stuck around this whole time, I think we're almost up to an hour or so since I started it. I know we had some tech difficulties, but thanks for, I appreciate you, one, coming late at 5:15 and then sticking around for the difficulties. Our next few meeting, every other meeting we have one tomorrow, will be at 3:15 normal time, and hopefully we won't have any hiccups or anything like that. All right, we'll look at the written questions tomorrow if you want to get a jump start on any of like starting at number 25 on the June 2015. I will see you guys in class tomorrow and after school tomorrow as well if you're coming to review session 4. Have a good day, guys. Thanks for coming and staying. Adios.